Okay, so in this video we'll see a complete solved example of decision tree. In the previous video we had only seen a partial example. We had only decided what is the root attribute. In this we'll see a complete example. So now there are 10 rows. The initial entropy will be, you can pause and answer this. Yes, the initial entropy will be 1 because exactly half of the rows have the label yes and remaining half of the rows have the label no. Okay, so the entropy is the highest when half of the rows have one label and the remaining half have the second or the other label. Okay, so the initial entropy will be 1. Then we'll calculate the information gain if temperature is the splitting attribute, if weather is the splitting attribute, if humidity is the splitting attribute, and if wind is the splitting attribute. Okay, so let's say we choose temperature as the first splitting attribute. Now 40% of the rows have the temperature as hot, 50% of the rows have the temperature as mild, and 10% of the rows have the temperature as cold. Okay, so therefore the weightage of the entropy, when we'll calculate the total entropy of the temperature, the weightage of the hot temperature rows will be 0.4, the weightage of the mild temperature rows will be 0.5, and the weightage of the cold temperature rows will be 0.1. Okay, now let's calculate the entropy for the hot temperature rows. So for the hot temperature rows, as you can see, 2 of them are yes, 2 of them are no. Again, exactly half of them are yes and half of them are no. So therefore the entropy of this will be 1. Okay, the entropy over here will be 1. This is the calculation. The weight 0.4 multiplied by the entropy. Then here the entropy will be probability of yes multiplied by log to the base 2 probability of yes plus probability of no multiplied by log to the base 2 probability of the no, and the entire thing applied with a minus sign on the outside because this value is going to be negative and we only want to deal with positive numbers. So we add a negative sign, or we apply a negative sign outside, or multiply by -1, you can think of it, and that multiplied by the weight, which is 0.5. So 0.5 times 3 by 5 log to the base 2 3 by 5 plus 2 by 5 log to the base 2 2 by 5. For this one, again, there is only one value. If there is only one value in any data set or any partition, if there is only one value, then the entropy will be 0. So here the entropy is simply 0. If you calculate, the value will come out to be 0.7884. And the information gain is, initially the entropy was 1. Initially the entropy of the entire data set without any splits was 1. And after we split based on temperature, the entropy reduced to 0.7884. So reduction in entropy is the gain in information. So information gain is 0.2116. Let's say we split based on weather. Now in case of sunny, one of them is yes and remaining 2 are no. Firstly, let's calculate their weights. What are their weights? Here, because 3 out of 10 rows are sunny, weight will be 30% or 0.3. 3 out of 10 rows are cloudy, weight will be 0.3. 4 out of 10 rows are rainy, so the weight will be 0.4. Okay, now for sunny, the entropy will be basically probability of yes multiplied by log to the base 2 probability of yes plus probability of no multiplied by log to the base 2 probability of no. In case of cloudy, it will be probability of in case of cloudy, as you can see, all the nodes are yes, so therefore there is no randomness, there is a uniformity. Basically there is no chaos, there is uniformity, so therefore the entropy will be 0 over here. In case of rainy, you can see that there is one yes and remaining are no, so the probability of yes will be 1 by 4, probability of no will be 3 by 4. Entropy will be 1 by 4 log to the base 2 1 by 4 plus 3 by 4 log to the base 2 3 by 4. Okay, and they will be multiplied by the respective weights, and the value you will get as 0.6. Information gain, initially the data set had entropy 1. After we split on weather, the entropy was reduced to 0.6. Reduction in entropy is the gain in information. So So the information gain is 0.4. Next we split based on humidity. So humidity can either be strong or it can be weak. So let's calculate the weights. Here 7 of the rows, 70% of the rows are strong, 30% of the rows are weak. Those are the weights, 0.7 and 0.3, right? And inside strong you can see 3 of the rows are yes, 4 of them are no. So 3 by 7 is the probability of yes, multiplied by log to the base to 3 by 7, plus 4 by 7 is the probability of no, multiplied by log to the base to 4 by 7. Similarly for the weak, probability of yes is 2 by 3, so 2 by 3 log to the base to 2 by 3 plus 1 by 3 times log to the base to 1 by 3, the answer will come out as 0.8651. And the information gain is 1 minus 1, which is the initial entropy of the data set. When you split based on humidity, the entropy reduces to 0.8651. So the gain in information is 0.1349. Okay. Finally for wind, again if you calculate their weights are over here. You have 60% of the rows have strong wind, 40% of the rows have weak wind. Those are the weights, 0.6 and 0.4. The entropy of the strong partition is 2 by 6. 2 by 6 are yes, so 2 by 6 times log to the base to 2 by 6. 4 by 6 is the probability of no, so 4 by 6 times log to the base to 4 by 6. For the weak, the probability of yes is 3 by 4, so 3 by 4 log to the base to 3 by 4 plus 1 by 4 log to the base to 1 by 4 multiplied by the respective weights, answer will be 0.8755. Initially the data set had the entropy 1. After we split on wind, the entropy reduces to 0.8755. So reduction in entropy is the gain in the information, and the gain in the information is 0.1245. So if we compare all the information gains, the maximum information gain was using the weather as the splitting attribute or as the root attribute. So therefore we'll choose weather as the root attribute, and this will be our first split, and then we'll repeat it for every other partition. Okay, so here weather is the root node, and weather created these 3 partitions. Now for the first partition, you can see again there will be some weights. So this will have 0.3 as the weight, this will have 0.3 as the weight, and this will have basic. Okay, now let's not do that. Each one of them is like a separate problem, like we had started. This is a separate problem of its own, this is a separate problem of its own, this is a separate problem of its own, right? Now if you consider this middle problem, it is simply entropy equal to 0, all of them are yes. In case of sunny, if I use now for sunny and rainy, these are like 2 small data sets that we got from the initial big data set. Now forget about the initial big data set, okay, that is gone. Initial data set given to you in the problem, printed on the question paper, that is gone. That has been split into 3 parts based on weather as the splitting attribute. Okay, now you only have 3 data sets, out of which cloudy is no question, no brainer. Iska label yes hone wala hai because all of them are yes. Okay, the leaf node for this is going to be yes. If the weather is cloudy, yes, the child goes out to play when the weather is cloudy. Now when the weather is sunny is like a separate problem, and when the weather is rainy it's like a separate problem. So it's like you're starting all over again, but with weather equal to sunny rows and weather equal to rainy rows. So when we start again with weather equal to sunny rows, first we'll have to calculate initial entropy of the data set. So what is the initial entropy of the data set? Initial entropy of the data set over here is initial entropy. There are only 3 rows in this partition. Initial data set has only 3 rows. What will be the initial entropy of this? It will be 1 by 3 times log to the base to 1 by 3, okay, minus 2 by 3 times log to the base to 2 by 3. This will be the initial entropy, whatever this value comes out as. And then we'll calculate based on different splitting attributes what will be the gain. Similarly for rainy, initial entropy for rainy, this was for sunny, okay, this is for sunny, this is the initial entropy of the data set for sunny. Then for rainy, initial entropy will be 1 by 4 times log to the base to 1 by 4 plus 3 by 4 times log to the base 2 3 by 4. This will be the initial entropy for rainy. Okay, now once you do that, and now focus on the different attributes. So weather is already done, so you have temperature, humidity and wind to consider. So if you consider temperature, the temperature will have zero entropy, right? Because hot has only one node throughout, so this is zero entropy, this is zero entropy, this is also zero entropy. So if you split sunny based on temperature, zero entropy, and if you split rainy based on temperature, there will be some calculations which we'll see now. So entropy of sunny nodes initial, so this is the initial entropy that I was talking about. This is the initial entropy of sunny is 0.9183. Entropy of its children is 0. So information gain with temperature as the next splitting attribute will be 0.9183. Initial entropy of rainy, this will always be 0.8113. And entropy of the children when temperature is used as splitting attribute is, if I see like this, so again you can verify the calculation. Hot is not in the calculation, cool ke liye it is 0. Only for mild we have to calculate. Basically it is 1 by 3 times log to the base to 1 by 3, because one of the 3 is yes and 2 of them are no, so 1 by 3 and 2 by 3. And the weight is basically 3 by 4. Weight for mild is 3 by 4, weight for cool is 1 by 4. But okay, so the value you get is 0.6887. Information gain is 0.1226. What if you use humidity as the splitting attribute? Again, for sunny, entropy of the child nodes is 0, so information gain is again 0.9183. For rainy, again we can have some calculation. Calculation is exactly the same, 0.6887. Information gain is 0.1226. For wind, now in case of wind, for rainy, the entropy is 0 for the children, and for the sunny, for child nodes, the entropy is this. As you know, entropy will be highest over here because one of them is no, one of them is yes, half. So entropy will be 1 over here, entropy will be 0 over here. Okay, so here the entropy is 0.6667 combined for the child nodes, because here the weightage is basically this is 2 by 3rd, right? This is 0.667, this is 2 by 3rd. Weight for strong, because 2 by 3rd, there are 3 rows in sunny, out of which 2 of them have strong winds and 1 of them has weak winds. So 2 by 3 is the weight of strong and 1 by 3 is the weight of weak. And this is 0, so this does not matter anyways. Okay, so information gain for wind as a splitting attribute is 0.2516 for sunny, and information gain for wind as the child attribute for rainy is 0.8113. Now let's compare all the information gains. Actually for rainy we have multiple choices. We can also use temperature, we can also use wind, they had the same information gain. And for temperature as well as weather, temperature as well as weather had the maximum information gain in case of sunny, and for rainy wind has maximum information gain. So therefore, of course, decision trees are not unique. So instead of after weather, if we had, I misspoke, basically initial was weather. Instead of humidity, you could also have temperature. And it could have also given you a decision tree, another alternative decision tree. Okay, so there are decision trees are not unique. Okay, that's the answer.